Aluminum silicate, or aluminosilicate, are the names commonly applied to a group of chemical compounds which consist mainly of aluminum oxide and silicon dioxide. There are a broad number of mineral sources that generate aluminum silicate byproducts and materials, and these materials vary widely in the matrix makeup that characterize these aluminum silicate residues. In an effort to understand some of the key fundamentals that drive the waste and recycling industry, we have developed a website, waste.net, to act as a tool to assist in grasping the 4R strategy of reduce, reuse, recycle, and recover. Within the 4R's recycling sector, we encounter many types of minerals, some of which pose particular challenges when it comes to resource recovery. Some of these challenges are technical in nature, but most commonly the largest hurdle to overcome is the economic rationalization to justify the recovery efforts. Some of the residual aluminosilicate materials that we attempt to address have been compiled into the following partial list of the most common types of residues. This list is in no particular order and only represents a small fraction of the mix of material we encounter. The types of aluminum silicate residues includes tailings wastes, red mud, gray mud, fly ash, baghouse dusts, electric arc furnace residues known as EAF dust, furnace slags, catalyst substrate scrap, ceramic and porcelain waste, refractory and abrasives recovery, spent zeolites and cryolite, mineral salts concentrates, alkali and alkaline earths waste streams, sludge, slurry, and solids residue, and filter cakes. We would like to focus in more detail on a few of the areas that may represent an underdeveloped opportunity in the recycling field. Mine tailings or tailings wastes are a byproduct of the metal and minerals extraction process. After the designated primary commodity of value is extracted from the ore material, the remaining waste stream is termed as tailings. Processing tailings wastes may reduce the potential of trace elements leaching, thereby reducing the environmental risk or liability, while increasing the resource recovery rate. Red mud. Red mud is produced as a byproduct of the Bayer process in the conversion of bauxite into alumina in the preparation of the raw materials in the aluminum metal refining process. It is estimated that between 1 to 1.5 tons of red mud is generated for each metric ton of alumina produced, and 2 tons of alumina is required to produce 1 ton of refined aluminum metal. It is also estimated that over 3 billion tons of red mud worldwide has been accumulated and is stored in what is referred to as bauxite residue tailings monofills and slurry ponds. Aluminum production accounts for the approximate current generation rate of an additional 150 million tons of red mud each year. On average, between 4 to 5 tons of bauxite is required to be produced into 2 tons of alumina, which yields 1 ton of metallic aluminum output, so this process generates between 2 to 3 tons of red mud for each ton of aluminum metal. Typical red mud composition may contain a wide mix of elements, including iron oxide ranging from 5 to 60%, aluminum oxide with 5 to 30%, silicon dioxide with 3 to 50%, and it also may contain a combination of less dominant items such as titanium dioxide, calcium oxide, and sodium oxide. Some red muds may contain other trace elements, such as mixed heavy metals ranging from 0.5 to 13.0%. Fly ash. Fly ash may be viewed as a type of aluminum silicate residue. There are a variety of types of ash, including coal ash and incinerator ash. Incinerator ashes are typically designated into incinerator bottom ash, IBA, and flue gas stack fly ash. These ashes may be further classified into Class F fly ash and Class C fly ash. Class C fly ash generally contains more than 20% lime or calcium oxide, and Class F fly ash contains a lower lime or calcium content. Fly ash may be used as a circular aggregate in the production of geopolymer concrete. Increased levels in carbon content can make the fly ash unsuitable for the use in the production of geopolymer concrete. The ASTM C618 specification limits, loss on ignition, LOI, must not exceed 6% in order to be acceptable as a geopolymer material. The chemical composition of fly ash depends upon the type of combustion fuel used, and the methods used in the combustion process. A typical average chemical composition of fly ash may contain major elements such as SiO2 or silicon dioxide, ranging from 55 to 65%, and aluminum oxide known as Al2O3, with a content of 25 to 35%. The balance of the content consists of a fringe mix of iron and iron oxides, and other oxides, such as calcium, magnesium, manganese, potassium, titanium, and sodium. Trace heavy metals may range from 0.1 up to 8.5%. Furnace slags. It is not uncommon for a melting furnace to utilize limestone as a part of the melting or reducing process. The molten limestone acts as a carrier for the accumulation of any impurities collected from within the process, and is expelled as a molten slag. The main components of blast furnace slag are a range of 30 to 50% calcium oxide, 28 to 38% silicon dioxide, 8 to 24% aluminum oxide, and from 1 to 18% of manganese and magnesium oxides. Trace elements and mixed heavy metals may total 0.3 to 9.0%. These slags are typically grouped into a classification included as aluminum silicates residues. One common practice is to reuse slag materials as a blend that is integrated into recycled aggregates in the form of materials such as ground granulated blast furnace slag, which is designated as GGBS. Spent zeolites. Spent zeolites may include spent natural or synthetic zeolite materials, ceramics and silicates generated from filtration mediums, semi-permeable membranes, and catalysts. The term zeolite typically refers to a family of several microporous, crystalline aluminosilicate materials. One wide common use of zeolite materials is as an ionic exchange resin utilized in common water softeners. Recovered zeolites may be beneficial in the efforts to decarbonize the energy infrastructure. In summary, regarding aluminum silicates recycling, by pursuing a methodical approach to the concentration and selective extraction of residual materials, we may be able to decrease the potential environmental hazards and liability, while increasing the rates of strategic resource recovery. We intend to explore the recovery of other types of minerals, metals and materials at some point in the future. Until then, please feel free to reach out to us at your convenience. Waste.net provides a neutral platform to assist in finding a market for scrap, waste and byproducts, with the goal of matching waste material generators directly with beneficial users of those materials. By connecting market participants, we foster collaboration and promote environmental sustainability. Please feel free to visit us today at www.waste.net.